Good morning friends. Today I am going to explain the expression for self-induction of a long solenoid. This is one of the important topic in electromagnetic induction. So before going to give the expression for the self-induction of a long solenoid, first of all we should know what is solenoid. A solenoid is nothing but it's a coil or a wire wound over a cylindrical frame uniformly. Its diameter is small as compared to its length. So now we are going to find out the self-induction of this solenoid. So for that purpose, first of all, we have to consider a solenoid of length is L. This is the solenoid whose length is L, and area of cross section of each turn is A. Here number of turns are there. So area of cross section of each turn is A. Now let N be the total number of turns. Here total number of turns is we are taken as capital letter N, and small letter n be the number of turns per unit length. So here we know that the number of turns per unit length can be written as total number of turns and by total length. So n is equal to n by L. Suppose a current I amperes flows through it. In the through it, the magnetic induction or magnetic field inside the solenoid is given by B is equal to mu naught Ni. So we know that according to the Faraday's second law and electromagnetic induction, whenever a current is flows through the solenoid, then the magnetic field is set up in the coil. So that magnetic field is can be written as B is equal to mu naught Ni, where I is what? The current flows through it, and small letter n is the number of turns per unit length, and mu naught is the permeability constant. Only for remembering, I wrote the note here. Mu naught is nothing but it's a ratio between the magnetic field, magnetic flux and magnetic field. And mu naught is nothing but it's a permeability of the free space, and its value is 4 pi into 10 to the power of minus 7 Henry. Okay. So first to calculate my self-inductance of a solenoid, first of all we have to consider a small turn or one turn. What is the flux through these turns, small turns, and after that we will calculate the whole. For that purpose, the magnetic flux through the each turn can be written as dou phi. We know that for smaller values we should have to differentiation dou phi p is equal to mu naught Ni into A. Here the total flux or the magnetic field is can be given as mu naught Ni. Now here this one is the magnetic flux through each turn. So each turn means we should have to introduce the area of cross section of the each turn. So that's why dou phi b is equal to mu naught Ni into A. So next, the total magnetic flux through all the turns, can be written as through all the turn means phi b is equal to mu naught Ni into A. So total turns are capital letter N. So that's why we have to introduce a capital letter N. So we know that we can write N is equal to capital letter N by L, or we can write capital letter N is equal to N into L. So if you substitute the value of this NL into this equation, then phi b is equal to the mu naught Ni into A into NL. So we can write finally phi b is equal to mu naught N into N square A I L. Okay. So this is the total flux, magnetic flux through all the turns. Okay. Now we know that self inductance is equal to the phi b, that is the self inductance of a solenoid is can be given as, so already we derived this equation in the last video, that is self inductance of the solenoid is can be given as phi b is equal to Li. Okay, so phi b is Li, and we can write this is equal to phi b value already we got, or we can write phi b value in this situation here, mu naught n square a I l. So that's why mu naught n square I a l into here is equal to the Li, and we can write both the sides I get cancelled, or self induction of a solenoid or self induction of a long solenoid can be given as mu naught n square a l, and self induction induction on is can be measured in Henry. So let us take this as equation number 1. So this is the expression, and also we can write this one mu naught, we know that n is equal to n by l, so n square by l square a l, and this can be written as l get cancelled, mu naught n square a by l Henry. Just take this as equation. So this is the self induction of a long solenoid. Self induction of a long solenoid. Thank you. For more videos, subscribe my channel Physics.